Okay, so now we know a little bit about NLP. In particular, we have seen some examples. One interesting thing in NLP is that when solving these problems, what we are really interested in is the semantics of the text that we have. But unfortunately, we only have the text. So we have to find a way to link these, the semantics between to link the words to the semantics. And this is actually something that is not always trivial. So we need to find an efficient way to do that. To give an intuition, so let's say we take a task that is called question answering. So it's basically just the task of answering some question. So here you see that I have this text, how is the weather now? And the output should be, it's raining cats and dogs. And here with the image, I'm trying to show the semantics of the text. So you see here on the left, we have the weather with a question mark. And on the right, you see that the picture is showing that it's raining a lot. So the intuition here is that when we have an NLP task, we are really interested in the semantics, so this part that I show in the picture, but unfortunately, we only have access to the text. And sometimes it's not so easy to link the two things. Like in this case, if you look to this sentence, it's raining cats and dogs, if you do a word-by-word analysis, maybe you think that we are talking about cats or maybe dogs, but in the end, the semantics is completely different from this. And extracting these semantics can be a non-trivial task. And we definitely would like to have some systems to help us to do this link between this text and the real semantics. And actually, we have some help there. We can use these two very interesting ideas that actually have been already mentioned, I think, in day 1 or day 2. So the first one is this distributional hypothesis, and the second one is the principle of compositionality. I will now show them more in detail. I will start with the distributional hypothesis. So it's an idea that it comes from 1954. So it says that words that occur in the same context, they tend to have a similar meaning. Or as it has also been said, you shall know a word by the company it keeps. So the intuition here is that words that are semantically similar, they will probably have a similar distribution in text. And this is really interesting because it's starting to, it gives us the intuition that we can create a link between a word, the context, and the semantics. And this will greatly help us because it can, in an indirect way, it is linking the words to the semantics. And we will see how we will build on top of this when we will talk about word embeddings. Here, there is just one example. So you see some text, and you see the word intelligence. And you see that this word tends to happen in context where we see the word humans. Like in all the 3 examples, there is the word human. So somehow the context is giving us some intuition on the semantics of this word. The other idea that we mentioned was the principle of compositionality. So this is a very broad idea that can apply to many, many areas. In fact, here you see in math, semantics, and so on. So it basically means that the meaning of a complex expression can be determined by the meaning of its constituents, which have been combined together according to some rules. And actually, we are using this principle since the very beginning of today, since the first presentation. Like in the very first example, the RNN that was solving the Alan Turing lived in England case, we were already applying this principle because we were trying to put together the various words, the Alan, Turing, lived, and so on, into a more higher level meaning, which was the internal state of the RNN, so that the RNN was then able to do the correct prediction for the output. Here we have one example on the principle of compositionality, and again, this is to stress how sometimes it's not so easy to correlate meanings to words. So you have again this sentence, it is raining cats and dogs, and again the picture are showing the concept here, the meaning, the semantics, and you see that this part here, it shows that it is raining, and then we have a cat, and then we have a dog. But if we put everything together, the real meaning is that it is raining a lot. So you can see that how this principle of compositionality, we are basically applying that to build some higher level meaning, but at the same time, there are definitely some cases that are not trivial to follow. Okay, so both this idea, the distributional hypothesis and the principle of compositionality, they can help us to solve NLP tasks, and in particular to try to link words to semantic. In particular here, the distributional hypothesis is helping us because it's kind of creating this link between words, context, and semantics. The principle of compositionality, it allows us to tackle this NLP task in a sort of hierarchical way, where we are trying to build the higher level meaning starting from the text. And these are two important ideas that are at the base of, for example, word embeddings. But before going there, we will start by looking at older and classical approaches. So how we were representing words in the past in NLP. And we will see that there are some disadvantages, and we will see how to improve in the next point, in the point after, with the idea of word embeddings.